In 9.2, we're going to find the missing sides of special right triangles. So we know how to find, using Pythagorean theorem, we already know, if I give you a right triangle, and if I know two of the sides, if I know this side is 5 and this side is 3, like we know how to find that missing side right there. That's what we're doing in 9.1. Well, there are certain special right triangles that come up a lot in trigonometry, which we're going to be getting into. And so if we're familiar with these, it allows us to kind of work more fluently with trig, okay, and do better with that. So the first one is 45, 45, 90 triangles. So go ahead and label this. So this is a 45, 45, 90 triangle. So this is 45, this is 45, and this is my 90. What that means is that this triangle is isosceles, right? The two angles are equal. If you want to mark it, that means those two sides are equal right there. All right, so let's say, let's start out, let's say this side is equal to 1. Let's say these sides are equal to 1, actually. So this side is 1. Well, that means this side is 1 too, right? Because the two angles are the same, the two sides have to be the same. Let's find that missing side right there. And what we want to look for is a pattern so that if I have a 45, 45, 90 triangle, we can find it really quickly without having to solve a right triangle. We just know the ratios and we can find the lengths of the sides from that. All right, so we're going to do Pythagorean theorem. So I'm going to take my two legs, they're both 1. 1 squared plus 1 squared equals x squared. So 1 squared is 1, 1 squared is 1. Add it together, we get 2. We take the square root. So x is equal to the square root of 2. So this side up here comes out to be the square root of 2. Well, the reason why that's helpful is if I take another 45, 45, 90. So let's say this one's a 45, 45, 90. Those two angles are equal, and it's a 90-degree triangle. Let's say, for example, that these sides are 5. Okay, both sides are 5. Well, I could do Pythagorean theorem, and I could, go through that whole thing and find it. But what I know is that this triangle, my big triangle, is going to be similar to this smaller triangle, so they have the same ratios. So if this side is 1, 1, and that side's the square root of 2, or you could say it's 1 times the square root of 2, then if this side is 5 and this side is 5, that means the hypotenuse has to be 5 square roots of 2. So now for any size triangle, if as long as it's a 45, 45, 90, if I know one side, I can find all the other sides. So here's what I want you to have. So write this down right here, okay, in your notes. So if I know the two sides of my 45, 45 triangle, right, the x and the x are the same, then the hypotenuse is just x times the square root of 2. Right, so in a 45, 45, 90 triangle, the hypotenuse is square root of 2 times longer than each leg. So again, now if I know one side of my triangle, I can find the other sides. So here's some examples. So if you look at this one, I've got, this is 8. Now be careful, this is 45. So this is one of the legs of the triangle. If it's 8, right, we know it's isosceles because the angles are the same, so that side is 8. So how do we find the hypotenuse? We take the legs, 8, and you times by the square root of 2. And we're done. That's all we have to do. Really quick, just to show you, if I did want to use Pythagorean theorem, I'd go 8 squared plus 8 squared equals x squared. 64 plus 64 equals x squared. That's 128 equals x squared. Take the square root. We'd have to simplify that, so we take 128 and break it apart. It's 2 and 64, 8 and 8. So we get an 8 on the outside and a 2 on the inside, right? That's the same answers we got up here, but I hope you all agree this is a whole lot easier if I just know that ratio. So if I know one of the legs, I times by the square root of 2 to get the hypotenuse. This one's going backwards, so now I know the hypotenuse, and I want to work backwards to find the legs of my triangle, to find out what x is. Well, then I'm just going to go backwards. Instead of timesing by the square root of 2, I'm going to take 5 square root of 2, and I'm going to divide by the square root of 2, because I'm going backwards. Well, that works out nice, because the square root of 2's just cancel out. That means x has to be 5. So there's the length of my two sides right there. All right, the other, we'll do some more practice those. We'll do a combination, but the other one I want to talk about is a 30, 60, 90 triangle. So you have this in your notes there. Go ahead, and then what I want you to do is I want you to draw the same triangle, that 30, 60, 90, just draw it off to the side. like that. So this is still a 30, this is still a 60, and this is still a 90. Well, if you look at that triangle together, if I put the two of them together, they form this bigger triangle that I'm outlining in green. And look at the angles of that triangle. All of them are equal to 60. So I have a 60, 60, and 60 all the way around. Okay, so what I'm going to do is I'm going to say this side is 2. Well, if you look at the green triangle, because it's a 60, 60, 60, it's equilateral. All the sides are equal. That means this side is 2. And on the bottom here, this entire length right here is also 2. Well, this is halfway. That means this piece is 1 and this piece is 1. Well, what I've done, I'm going to erase that other half of the triangles. What I've done is I've just shown you that if you have a 30, 60, 90, if you have the hypotenuse as 2, this 30-degree angle down here will always be half of the hypotenuse. So if it's 2, it's equal to 1. Let's find out what the third side is. So I'm going to put an x over there. I'm just going to use Pythagorean theorem. So I'm going to go 1 squared plus x squared equals 2 squared. So that's 1 plus x squared equals 4 minus the 1 over x squared equals 3. Take the square root. We don't have to worry about the plus or minus because it has to be a plus. So this side over here comes out to be the square root of 3. Okay, so this is really important. If you have a 30, 60, 90, if I take the short leg, it's the leg opposite the 30-degree angle. If I times it by 2, I get the hypotenuse. If I times it by the square root of 3, I get the long leg, the one opposite the 60-degree angle. So this is a new ratio, and you have this other triangle written off the side. Go ahead and fill it in. We're going to say if this side is 30, this angle is 30, this one is 60. If I know my short leg, the short leg is the one opposite the 30-degree angle. It's equal to x. To find the hypotenuse up here, I just times it by 2. So I go 2 times x. To find the long leg, I just times it by the square root of 3. So I go x times the square root of 3. So these are the ratios, and you're just going to memorize these. You're going to memorize the 45, 45, 90, and you're going to memorize the 30, 60, 90, and you're responsible to know those. So this is what we just said, right? If I know the short leg is x, the hypotenuse is 2 times x, and the long leg, you take the short leg and you times by the square root of 3 in order to find that. All right, so let's do a couple of examples. You can see what this looks like. So if you look at this one, it says find the values of x and y. Write your answer in simplest form. This is really important. Make sure you identify the side that they gave us. So they gave us the 9, which is opposite that 60-degree angle. That means it's the longer leg. That's what it gave us. So remember our ratios. I'll write it off here to the side. If I have a 30, 60, 90, I take the short leg, I times it by the square root of 3 to get the long leg, and then I times the short leg, right, this one, by 2 to get the hypotenuse. So we have to go backwards here. So normally I take the short leg and I times by the square root of 3 to get that leg. Now I'm going backwards. I have the long leg and I want to work backwards to find that one. Well, what I do then is instead of timesing by the square root of 3, I take the 9 and I divide by the square root of 3. Now to do that, you have to remember some stuff we learned last trimester. And that is we have to rationalize the denominator. And what I mean by that is we don't leave a square root on the bottom. So to get rid of the square root of 3, we times by the square root of 3 on the top and the bottom. So what happens is on top, I end up with 9 square root of 3. But on the bottom, I have square root of 3 times the square root of 3. That's square root of 9, which is 3. It comes out just to be 3. And now I can divide those two. So this short leg comes out to be 3 square roots of 3. A little bit tricky, right? Now I want to go from, now that I've got the short leg, I want to find the hypotenuse. Well, to go from the short leg to the hypotenuse, we take the short leg and we times it by 2. So this side, I'm going to go 2 times 3 square root of 3. Well, I can times the 2 and the 3 together. That ends up being 6 square root of 3 is what it comes out to be. So if you know one of the legs, now with Pythagorean theorem, you'd have to know at least two of the sides. But with if you know these special right triangles, these 30, 60, 90 triangles, or the 45, 45, 90 for that matter, if you know one leg, you can find the others. Okay, so here's just a bunch of a big mix here. So we've got to decide, is it a 45, 45, 90 and find the missing side, or is it a 30, 60, 90 and find the missing sides? Okay, so let's start with this first one. It doesn't tell us what the angles are, but notice that this side and this side are the same. That means they're equal. That means it's isosceles, so the angles have to be the same. So this is a 45, 45, 90. Now, normally I take x and I times it by the square root of 2 to get this. So I'm going to go backwards. I'm going to go 2 square root of 2 and divide by the square root of 2 to find that. So those reduce. So x has to be 2. Okay, and we've solved it. Let's come down here and do this number 4 right here. So it wants me to find the height. Now I want you to notice something. It's a little bit tricky. Identify what kind of triangle this is. So this side is 4 and that side is 4. They're equal. If you look at this entire side, it's also 4, right? The entire thing, because it's 2 and 2. So this thing, the one I just outlined in green is a 60, 60, 60. It's equilateral. So label this side. This side is 60. This side is 60. And this height is splitting in half. So this one up here has to be 30. So if I just take one of those triangles, I'm going to make it a little bit bigger. It's easier to see. It's a 30, 60, 90. This side is 2 and this side is 4. And it wants me to find the height, right? It wants me to find that. So we're finding this side right here. Let's put an X over there. So always start by identifying which side you know. If this is the 30-degree angle, this is the short leg. It's equal to 2. So I know the short leg, which is good. If I know the short leg, to find the hypotenuse, I times by 2, which that's 4. To get the long leg, we times by the square root of 3. So I go the short leg 2 times the square root of 3. That's my answer. That's what the height is. And the height's right there. Comes out to be 2 square root of 3. Okay, I want you to pause the video. I want you to try number 2 and 3, and then come back and I'll go through it with you. And if we got that, that's it. That's all you need to do. All right, let's start with 2 up here. So identify what kind of triangle it is. These two sides are the same. They're equal. That makes it isosceles. That makes it a 45, 45, 90 triangle. I know the legs. So to go from the legs to the hypotenuse, we times by the square root of 2. So I'm going to go square root of 2 times by the square root of 2. Well, square root of 2 times square root of 2 is the square root of 4, which is just 2. So that's what y equals. Comes out to be 2. Okay, let's do this one down here, number 3. So identify what side it gives you. So this is my 30-degree angle. That's the opposite side. That's good. We like that. That is the short leg. So if you know the short leg, to find the longer leg, we just times it by the square root of 3. So square root of 3 times the square root of 3. Times those, that's the square root of 9. So x has to come out to be 3. Hey, it didn't ask us for the hypotenuse, but we could find it. If you know the short leg, you just take the hypotenuse and you times by the square root of 3. So that would be what the hypotenuse equals. So we just have to, what you're going to have to memorize, right, is you're going to have to know with a 30, 60, 90, like we're going to have to know this relationship right here. That if I know the short leg, I times by 2 to get the hypotenuse, and I times by the square root of 3 to get the longer leg. If it's a 45, 45, 90, then I take the legs, x, they'll be the same, and I times by the square root of 2 to find the hypotenuse. Or if you're going backwards, you could divide by the square root of 2 to find that. Okay, but that is everything you need to know for those special right triangles.